I have come to talk about mathematics and computing science, especially notation, meaning what we write. But I like to talk with you. So, a few things I will say and ask you. The first, it's okay? Of course, we are talking about mathematics. We can say math, it's okay? All right. And I like to focus today, because we'll be very short. I like to focus on math notation. So I will say a little bit about what we write. Maybe you all know there are some problems with what we write. We must think about it a little bit. And then I hope we have some time to talk about notation for today, the modern time, and also into the future, because we will try to speak mathematics to computers. So I'd like to talk a little bit about computing notation. Okay. Let's see. First of all, I already gave you a little hint. What we write in mathematics. First of all, do you like mathematics? How many of you like mathematics? Oh, okay. Yeah? A few. Oh, more, okay. So, this is good that you like mathematics. Some of you like computers? Yeah?
Yes.
Okay. How many like computers? Okay. All right. Well, of course, computers and mathematics, they go together. So, we are in good shape. Now, first I write something here, and now I want to erase. Oh, good. You see, very good to have a wife. You will see. Okay, no problem. It's technology. Okay. So maybe technology always had little problems, but technology has power. Yes. All right. So in mathematics, we can write things like this, of course. And we just look at it carefully for a minute. Of course, we know these are numbers and this is a function. But please look, the function is in between the numbers. No problem, you do that. You know. Do you use this? Yeah? Okay. Well, but we also have other ways to write multiplication. I'm going to say, I think what we write is important. We must look at it carefully. If this is multiplication, then what about this? We write this, you know, 4x. X often used as a variable, right? In the textbooks. Does not have to be x. For any letter. What does it mean? Multiplication, right? Of course, you know. But where? Where is the symbol? Why no symbol? In the history of mathematics, there is a good reason. Because we want to write polynomials. And we don't want to always have to write the multiplication. But think, when you are a young student learning multiplication, you are taught this, and then you learn algebra. You are taught this. So you have to learn that there is no need to write multiplication, even though it means multiplication. Of course, you also learn this. It means multiplication, but we don't see it. Why? We don't ask. Right. We just learn it. Okay, no problem. Easy enough to learn, right? But, as we will see, because we are now in 2011, almost 2012, we cannot write this kind of thing to computers. No good. We have to write multiplication symbol. In fact, we can write you have seen this? Okay. Many computer languages use this. Do you know why? I don't hear anybody. Do you know why? Why is it okay for multiplication? You already know. This is multiplication symbol. Somebody changing the rules.
Not to confuse with X.
What?
Not to confuse it with the X.
Yes. Also, thank you. That is a good reason. You look on the computer keyboard, so-called ASCII keyboard, because it is used for computer languages and has the ASCII code, you know. But anyway, you cannot find this symbol on your keyboard. You can find this. You can find this. You cannot find this. So, we are starting to see different ways to write multiplication. Also, we have this. You have seen the little dot. It means multiplication, right? Okay. And when you study linear algebra, you have seen this. Another way to write multiplication, but this time it's for linear algebra. Look, there is no multiplication symbol. You must learn this. Another thing to learn. Well, of course, it's a different kind of multiplication. Rows and columns and add it up. So actually, this has two functions, multiplication and summation. But we have to just learn this. We don't see the symbol. So already I am saying that we have some mathematical notation that does not use the symbol. We have some symbols, have many different, some functions that have many different symbols. This can be confusing, especially for computer. But also think, when you're a young child, why? Why is this so confusing? Maybe that's why so many of you do not like mathematics so much. Difficult to learn, does not make good sense. Oh, now, I didn't do the next one that you learn in elementary school. Do you remember this one? Do you use it now? No. You cannot find this on the keyboard. You do not use it in the university. No. What do you use? Okay, so this is good. We now have a symbol for this, for exponentiation. Also, in mathematics, we do not have a symbol. You have to know. I write a little 3. It's no good to write a big 3. No good. So, sometimes teachers, they are writing fast. Which is it? We don't know. We don't know. Maybe another reason you do not like mathematics. The teachers write too fast. Or they don't explain enough. Whatever. So I was saying, this is good for exponentiation because now, for doing computer work, we have a symbol. All right, now this is all very easy for you because it's from when you are young. But as you learn more functions, let's look at syntax. You know, the structure of what we write. This is important. I do not hear teachers talk about syntax of mathematics. Why not? Mathematics is the language of science. Mathematics is a language. It should make sense. Well, let's see. Let's see. Remember, these functions you learn at the beginning are in between the inputs. Okay, if I call these inputs. All right. Well, so you would think when you learn more functions that have 2 inputs, you would always put the function in between. And then, what about functions with just 1 input? What do we do? Well, because we have minus, you can see this. Now, actually, you write this, but you say -3. This is smart because this is not really a function. It is only describing what kind of number, meaning it's not positive, it is negative. So we have adopted a convention to write the symbol first, then we put the input. Okay, and we even have more functions that do the same thing. Now you know this function, and another language. This is old Greek symbol, but does not matter. We could put A, we could put X, we could put Y. It is the input, and it has the same syntax. You can see. The function is first, and the input after. Okay, so you say, good, we are starting to make sense. Then when I learn new functions like cosine, I will always do that. Okay, fine. You know all trigonometric functions, no problem. So, well, here comes another function with one input. It's called factorial. How do you write factorial?
Exclamation mark.
Yes. Okay. First or before the number or after?
After the number.
After the number.
Yes.
Wow. Why? Why? You just like this, and now you are going to change. Not this? No good? Why not? Why not? Okay, so you see now we have some functions that have the input on the right. We have some functions, input on the left. Can you think of any function has the input in the middle? Left, right, middle. Can you think of a function? When we write, I think you know. You know this, absolute value, or in complex numbers, it is magnitude. Here I use a variable because you don't know. Is it positive, negative, or zero? But look where I write the symbol. Actually, I'm using two symbols. Hey, who says we can use two symbols? It's okay, right? No problem. You know this one. Again, we borrow symbols from other cultures. Yes, okay, fine. And we write things like this. You have seen this. You have seen much more interesting things. But look at the syntax. This is the function. This sigma symbol is first. Then the input, just like these. But also, I am writing down low. I am writing up high. This is all part of the symbol. So, this is the function. This is the function. These are the functions. This is the function. These are the functions. This one too. So, in mathematics, we can do anything we want. Does not have to make sense. Well, now, mathematics has a lot to learn. Congratulations to you. You have learned a lot already. And you have learned some things that do not make sense. Good for you. Yeah, wait till you get married. Whew. Many things don't make sense. Okay, you don't believe me? All right. So I have shown you some very simple examples of things that don't make sense. Now I come to something important about what we write when we are doing mathematics and when we are learning mathematics. We are learning more and more functions, right? In fact, algebra is really defined as the study of functions. You learn more functions, more functions. So why are they all so different? Now, here comes the crucial issue. Well, if we are learning more and more functions, then I have a question for you. How do you decide which function to do first? not use this, okay? We have two different functions in this expression. Which function do you do first? Why? Multiplication is stronger. No? Well, all right, whatever. You just say, okay, I will learn this. Now, what happens when we have more functions? Which function to do first? Maybe this example is too easy for you because you are looking over here and you like to do this first. But suppose I write, well, let's just take this first. You say, do this first. Okay. But when I start learning more and more functions, I need to know which ones to do first. If I write for you an expression with sign, it's a function. Which function to do first? Too easy, right? I think you will do this one first. Does this mean sign is stronger than multiplication? Maybe. You would have to learn this. So, if sign is stronger, you agree, right? Everybody agree? Okay, good, 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 good. Okay. So, you can read this. What does it mean? Sine of 2 theta, cosine 2 theta. I don't see any multiplication symbol. So how do I know what to multiply? You know. This is the expansion of the sine of 2 theta. It is equal to this. Another thing you have memorized. But did you think? Did you think about this? This is why I am here. I like to ask you to think about what you are learning, your mathematics that you already know, and using mathematics with a computer. We must think. Let's look at this. You tell me sine is stronger than multiplication. So, I should do this first. Right? Sine is stronger. Sine of 2 radians, comes out to about. Sine of 2 radians, about. Sine of pi radians is 1, so a little smaller. Let's say 0.8. I don't know. This is where a computer is helpful. I don't want to know all this up here. Whew. Anyway, you tell me I should do this first. No. No, you will get it wrong on your exams. You will get it wrong. This must be do these. Sine 2 theta. This is what you have learned. I think you have learned. Yeah. Okay. So sine of 2 theta is done first. Then we do the multiplication. Okay. Oh, don't forget. This 2 theta, we have to do this first. Two times theta first. Hey, wait a minute. Hello. We are saying do multiplication first, then do sine, then do multiplication. Something is wrong. Which one is stronger? You told me sine is stronger than multiplication. Okay, but here multiplication is stronger than sine. So, should we give up? Okay. Actually, there are many things that are worth talking about. I have already mentioned to you some functions that have no symbol. We need to have symbols for all functions in mathematics in order to be using the computer. And some languages, like the language of J, which comes from APL. You can Google, you can learn J, but be ready. When you learn J, everything has to make sense. We don't have these rules. We have simple rules that are general. The rule for evaluating any expression is a single simple rule. We don't have a hierarchy of functions, which is stronger. No, it depends on how you write it. We don't have enough time for me to say much to you now about these languages. But be ready for the future, because we want the future to make sense. I give you just one more function I think maybe you find interesting. Sometimes we use one symbol for many different kinds of things in mathematics. Sometimes the things are not even functions. I give you a favorite symbol. So, how about nice symbol? Well, if you are careful, the lines are the same. So it tells you it means equal. All right, fine. What is equal used for in mathematics and in computing right now? Many different things. Okay, you have seen this. No problem, right? Is this a function?
Yes.
No. No. Oh, so, no. No, not a function. We also write things like this. I'll give one you can do in your head. Is this a function? No. No, not. No. This symbol, is it the same use as this symbol? Same kind of thing? No. No. This is for assignment. This is not assigning anything. It is expressing a relationship. Some expression here equal some expression here. And then, of course, your job is to find the x that makes it true. Ah! You can think of this as a job for you. We also write things like this with equal. Is it a function? No way. Same symbol. Is it an equation? Like this. This is equation? Is this equation?
Yes.
No, 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 sorry. Sorry. I tell you why, I save you a lot of trouble. If this is equation, please tell me theta. Solve for theta. You are too busy. Very many thetas work for this. It is an identity. You have heard this. Meaning always true. So it is not this, it is not this, it is different. Well, of course, we have, in computer programming, we have predicates. Yes, you write things like this. You know, go to, do something in a programming logic, meaning there is a sequence of commands coming, and then you hit this and you see this symbol. We have no problem using this symbol. Is this assignment? Looks like this. Is this an assignment? No. How do you know? Okay, so you need English. You need English to tell you what to do in mathematics. Ooh. We should know, what is this? This is a predicate, meaning it will come out true or false. Okay, is that enough? There are more uses of equals that maybe they don't make sense. But this is a favorite symbol of many people, not just me. So, what should we do? I think we should make equals a function. So, in J, if I write 3 equals 3, it will give me an answer. It will say true. How? It says true. Boolean. We know a function accepts inputs, always gives a result, unique result. So I think we should have the result be Boolean. So this is a question. And we have many, many functions like that. Not equals, less than. But they will all make sense. They will be functions. You know what? I think I haven't heard too much from you. I like to hear a little more about what you think about notation, and maybe also what you study in mathematics that you like, or computer that you like. So, can we start? What do you like?
Playing with it.
Playing. Okay. go to J because you can type mathematics expressions and play. Now play is just an informal word for experiment because he's going to be a scientist. And he will have to say, oh, I'm experimenting. Really playing. Okay. What are you interested in? Mathematics. Yeah, sure, go. Nothing, okay. In J, we can write nothing. Please. What is the difference between this and this and this? And you have so many letters. You have, and you have, you have so much in Hungarian, all the little dots and the agyű. So you are used to symbols, right? What is nothing? It is something. I don't mean just a word, because nothing is a concept. So maybe what your friends have in their head, nothing. It's a concept, but what do we write to make nothing? I think I gave you just one little example of J. Do we have time? 5 minutes? Uh-oh. Wow, we must hurry. So, here is something you can do to play right away in J. Here is a function. We actually write in J with I and a dot. No problem. If I put input, notice input on the right. All J functions with one input, input on the right. This is the result. A vector or a list. So, you like to play? Input. Somebody. Input. I be the computer.
8.
8. Did you say 8? It's so small, easy. I can do it. Now you know what this function does? Yes. Right. Creates an axis of integers, meaning counting integers, starting at 0. Why 0? Why not 1? Your mother taught you to count. My mother taught me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She didn't say 0. Why? Because I am something. All right. So, let's go the other way. Somebody tell me, what is the result? Okay, so you can see, you can study this, you can play when you are very small. But let's come to something. No problem. I hope you are noticing the pattern. Mathematics is about patterns. You study fractals? Yeah, beautiful patterns. Okay, there are patterns of numbers, there are patterns all throughout mathematics. You can see the pattern already. What does this number tell you? It tells you how many integers to give starting with 0. So we will go 0, 1, 2, up to 3. Stop before 3. So watch that now because we are getting to something. How many numbers? Up to 2, starting with 0. Yeah. Okay. Now, where is Mr. Nothing? What is the result? Right. Nothing is printed, but is something, because all of these results are vectors. This is the null vector. So I guess this means nothing more for me to say because we have to go. So, kusuno.